With an increase in cloud resources and its availability, individuals and enterprises are more empowered than ever before to create more content. Attackers are also leveraging the same. Our talk today is focused on an introduction to cloud security, how attackers are leveraging the cloud at every stage of the kill chain. All right, so while cloud security is a very large topic, we will be addressing today an introduction. So we're focusing on the definitions, talking about the threat landscape, the case studies, and then finally we'll be talking about some resources to take away. Hello, my name is Kim Huynh, and I am so excited to be a part of the FlowCon community. I'm looking forward to meeting everyone today. A bit of background about me: I worked in the healthcare vertical, focusing on incident response and threat intelligence as a security engineer. I've also had experience working with the Washington state government entities to analyze real-time network traffic for them through something called the Pisces Project. So essentially all of this meant that I had a lot of time trying to identify and see what is bad so that we can protect our own systems, processes, and our people. As they say in cybersecurity, we win by being able to stay to play in the game. So knowing what is bad and seeing what is bad is an incredibly important part of being able to stay to play. Now I get to work in threat intelligence security research, working to support our endpoint security team to be data-driven and customer-obsessed so that we can empower other teams like my old one to be able to take action on the data and insight that we have here at Microsoft. So I also have a history of involvement with the community. I'm very passionate about DEI and STEAM. I've been involved with WESIS, a nonprofit that's dedicated to empowering women in cybersecurity for many, many years. I am also on the board for the WESIS Washington affiliate chapter as well. So thanks for having me.
Hi, everybody. I'm so happy to be here with you today. My name is Remi Cohen. I've been working for F5 since I left the public sector. My security work has been a little bit all over the place, working on the right side, now doing a little bit more defending work, threat intelligence. But the common thread that's run through it has been my love of data. My master's is in industrial engineering, and I've done a lot of statistics and optimization. So I really liked being able to dig into the data on this during this talk. My team now also works on assessing risks related to hybrid and multi-cloud environments. So this has been a really relevant research project for me. So let's dive right in. So is cloud security even real? Now, gut instinct here is to say, yes, of course it is. I can buy cloud security products, go to cloud security talks, and some of you may even work in cloud security. So yes, it's real. But there isn't always clear guidance on how to consider it in a way that doesn't put it on a pedestal. A lot of industry's current approach to cloud can be seen as extremely distinct. There's a lot of new terms, new products, and they tend to be incompatible with non-cloud environments. If we were to view cloud as just another technology, for example, such as databases that have their own vulnerabilities, it would make sense to refer to specific applications of security related to technologies such as database security. But you wouldn't necessarily separate your database security teams from your other security stuff. The issue that we're going to get at here is that it's not an issue with definitions, but in how companies think of this term and apply it to their current operational practices.
All right, so before we dig into how attackers are leveraging the cloud, we wanted to clear things up related to the actual definition of cloud security. We sought out and identified 32 distinct definitions, and out of these, we found that they were very general. They were still copied off of each other, and then some even off of the Wikipedia entry. So with the 32 that we had in hand, we processed them as input through OpenAI with the intent to have a more comprehensive and complete definition at the end. So what it came up with was that cloud security covers the cloud platform, the data and people, and technologies. These categories could be further defined as cloud-focused security and compliance. While that was an interesting definition, it was not complete enough, so we put that through OpenAI once more. And here's what it came up with. Unfortunately, cloud security hasn't evolved with a broader security and compliance infrastructure around it, and in today's world is largely unregulated and standardized. All right, so here we're taking a look at NIST's definition of cloud security. Though this is older, from 2012, we still thought that it was very relevant. And what NIST says is that cloud security is a concept. It does exist, but its definitions and applications are not necessarily unique from traditional security. So in order to protect our cloud assets and resources, we have to demystify the concept that cloud security is innately separate from traditional security. Rather, it's something that we can build off of existing security controls that we are aware of and understand. So in summary, the lack of standardization, the broad scope that exists for where and how cloud applications are used, causes cloud security to encompass all aspects of traditional enterprise security. The things that we are familiar with and are important that exists inside of traditional security is still important when we move to the cloud. There are just nuances that we need to consider. Some are taken care of by the service providers, but it is still our responsibility as well.
Now, we use these words, so let's level set for the purposes of this talk, on what they mean. Cloud infrastructure is used to describe the components needed for cloud computing, including hardware, abstract resources, storage, and network resources. Think of cloud infrastructure as the tools needed to build a cloud. Cloud malware are programs with which cloud applications are hijacked into becoming transport mechanisms for malicious code. The accessibility and interconnectedness of modern cloud environments means that a single piece of cloud malware can travel far more easily around a target environment and cause more damage. A security incident, according to NIST, is an occurrence that actually or potentially jeopardizes the confidentiality, integrity, or availability of an information system or the data a system processes, stores, or transmits. Lastly, what's not up on the screen is a cloud-enabled attack. This is an attack that's not restricted by the traditional attack surface of on-prem malicious actions. For example, think of attacks on the cloud-to-user interface that results in an attacker impersonating a legitimate user towards the cloud system.
All right, I think we all know that cyber criminals will continue to target and abuse really the most trusted and popular platforms and services. Netscope and SANS identify that the top 4 industries that are most affected by cloud security includes the finance, technology, government, and then finally professional services. All right, so here we're highlighting the difference between what people had thought of as the most important concern for cloud security versus what was the most important by impact. So SANS asked security professionals to identify their biggest concerns in the cloud as it relates to the business applications, and then which ones were actually realized. So major concerns that were identified by security professionals, they had said unauthorized access, concerns around configured interfaces or insecure interfaces or APIs, and then lack of skills or training, and finally lack of visibility into the data itself. Now, what was actually reality? The reality was that there is a lack of skills or training within the many organizations. Next was that there's a lot of configured or insecure interfaces or APIs that can be associated with a lack of training or follow-through on best practices themselves. All right, so let's take a look at what organizations are identifying as what they are prioritizing. This is based off of the surveys and research from SANS and ICS2. So what we're looking at here is the percentage of attacks that were identified by those who were surveyed and their focus. The top 5 seen by the SANS survey is the accounts or credential hijacking, misconfiguration of the cloud services and or the resources there, the insecure APIs or the interfaces that were compromised, the DOS attacks, and then any crossovers from other hosted cloud applications. And the top 4 that were seen from ICS2, the misconfiguration of the cloud platforms or the wrong setup, data exfiltration, unauthorized access, and then finally the insecure interfaces or APIs themselves. One thing we do need to take into consideration is that while these concerns are legitimate, we do need to consider that they can be overshadowed by the growth of the attacks due to the rise of the remote work during our pandemic.
Now, I know this graph looks very complicated to start with, and I promise I'm going to break it down for you so that it's not quite as confusing. We often talk about the victims in cloud attacks, but malicious actors are using cloud infrastructure to conduct these attacks as well. What you're looking at is honeypot and sensor data collected over a 1-year period, limited by ASN number. This data is provided from F5 Labs. Malcolm Heath, specifically on the team, was able to gather it, and it's cleared for public use in presentations. We looked at 300 cloud service ASNs and associated attack traffic that F5 Labs is able to provide. Before I dive in, let me orient you to the graph a little bit. The x-axis is showing the months, and the y-axis is a logarithmic-based scale so that you can see the relative differences between the different ports, attack traffic over different ports. There are some limitations to this data, and I'll talk about that in a minute as well. But what the graph is essentially showing, which ports and services are the top attacked. A few key takeaways that you can see just from looking at this is that attackers go after the same ports or services, whether or not they're leveraging the cloud. What we can also see here is that there's a huge quantity of attacks that are leveraging cloud-based attacker infrastructure. The y-axis is the log-based 10 scale, and it's showing that this traffic isn't really targeted or crafted attack traffic to specific organizations. So there's just widespread activity here. The relative spikes could indicate the flexibility of cloud infrastructure, allowing attackers to scale up and scale down as needed. As I mentioned, there are some limitations around this data. While we noticed that there was widespread scanning data, the data has been normalized and scanning activity was taken out, so that what you're really looking at is attack traffic, even though it's widespread attack traffic. So now, taking an even closer look at 7 of the most commonly targeted ports, this chart really shows just how massive those spikes in attack traffic are. Again, across the bottom is months, but now on the y-axis, we're really going on specific numbers of attack traffic that we're seeing. And so it's a little bit different. It's not quite as easy to compare as with a logarithmic-based scale. So again, this chart is now showing some of the recent attack traffic that we're seeing and the patterns with some of the most, with the ASNs that we're seeing attackers leverage the most consistently and some of the least used ASNs in this data set. Before I dive into this chart though, I wanted to back up a bit and talk about ASNs. For those that don't know what ASNs are, they're autonomous system numbers and are a globally unique identifier that defines a group of one or more IP prefixes run by one or more of the network operators that maintain a single, clearly defined routing policy. So public and private cloud providers often have their own ASN numbers. And along with that, we also looked at ASNs who interact frequently with cloud providers such as Cloudflare. When it comes to looking at this attack traffic that came through these ASNs, we eliminated scanning activity and normalized this traffic because the number of honeypots and sensors did change over time. This chart is again on a log-based 10 scale, so you can better compare the differences in the magnitude of traffic passing through these ASNs. Out of the 300 ASNs we looked at, only 4 appeared consistently in the top 10 ASNs attackers are leveraging in order to conduct malicious activity. Their names are on the screen here, and notably, since this is honeypot and sensor traffic, there's a strong chance a lot of this traffic may be trying to install crypto mining software. This can't be confirmed this time because these weren't always interactive honeypots, but it's one of our working hypotheses. Another notable thing here is that you might not see any of the biggest cloud providers on this list. At first I was surprised by that, but it made sense once I was digging into this a bit more. Those companies are quick to shut down abuse, so why get banned for non-targeted attack traffic? Further, this traffic gets sustained, so it makes sense that attackers are leveraging ASN infrastructure that will allow them to continue working. Another hypothesis around this is that those providers are being used for more specific attacks, and that's something that we'll talk about later in one of the case studies. There are many reasons for this activity, and this talk is just providing a peek into how attackers are leveraging and targeting cloud infrastructure in order to conduct attacks. There's even more work to be done as policies continue to be developed in this space. The cloud enables large-scale attacks and even faster widespread distribution of malware. Along with that, crypto mining is a thing, and it's going to continue. Why use your resources when you can use someone else's? There isn't good international policy around this. As the recent policies China put into place take effect, we'll get a better sense of how effective they are. Right now, it appears that there's a large underground crypto market happening in China. Lastly, the cloud is cheap, but switching service providers could speak to relative availability and cost. Now over to Kim for the impact landscape.
So many of the services that are likely to move to the cloud first to benefit from the scalable resources, the reliability, availability, among with many other benefits, are going to be customer facing. These can be data processing or storage directories. They can be administration or individual employee data storing applications. Think of it as maybe HR, mail services, and even more. So these servers are then left public facing. So what happens to them next? They become valuable targets for direct brute force and exploit-based attacks. And we know that while botnet families have been around for decades, there's a new crop of highly effective and edge service targeting malware that's looking at databases and mail services in order to infect them at a large scale compared to traditional workstations. So from an attacker's perspective, this means that cloud-enabled attacks are largely free, scalable, or cheap. They are simple to orchestrate. Attackers have the tools that they need to leverage them. And they also are very motivated because why not? From a defender's perspective, the cost, responsibility, the scope, and the specialized skill that's needed to secure the cloud increases the complexity of our defense that we need to take into consideration.
Most people here will have heard of SolarWinds, so I'm not going to go into extreme detail. But the summary is that attackers were able to gain access to networks and data of thousands of SolarWinds customers when a malicious file was submitted as part of a routine update and created a backdoor into thousands of customer environments. The breadth and severity of this hack is unprecedented and was one of the largest, if not the largest, of its kind ever recorded. The cloud was used in a couple of different ways in this attack, and it shows the ubiquity of cloud resources in supply chain attacks. First, the attacker was a customer of cloud providers. They used AWS to set up command and control C2 infrastructure on Amazon, and they used Azure to set up DNS infrastructure to resolve the domain name used by the malware. So attackers using these services really made it possible to carry out their attack. When the malware requested domain names in the DNS servers hosted in Azure, return the IP addresses for the C2 infrastructure hosted in AWS. The victim was confirmed, and commands started to be sent to the malware on the SolarWinds host. Second, the victims also often had hybrid cloud environments. One of the key actions SolarWinds attackers took after establishing a foothold on networks was to target the systems that issue proof of identity used by cloud-based services and to steal the means to issue those IDs. Once they had this, they could create fake IDs that looked legitimate. This allowed attackers to access data and email just like legitimate users, including those with total access and administrative privileges. The big takeaway with this is that SolarWinds highlights how hard it is to get hybrid multi-cloud security right. By exposing the weaknesses in hybrid cloud authentication and least privilege, this attack really just shows how vulnerable every business is. But, as we've mentioned, the cloud is used in many types of attacks. The following case studies go into more detail on the variety of ways the cloud is used at different stages in the attack chain.
All right, our next case study covers a popular information stealing malware. It's been active since at least 2020, and it's been known as Jupiter, Solar Marker, Polizert, along with many other different names. But the malware itself propagates through abusing legitimate search engines, and it surfaces malicious pages. It does so by common keywords that users are looking for, such as templates, instructions, advice, or product pages. It abuses SEO without having to purchase advertisements by stuffing keywords into documents that are hosting on S3 buckets or CDNs. Those documents then contain links to malicious documents that infect the user with Jupiter by masquerading as .pdf or .doc files. Once infected, persistence is unestablished, the credentials and system information stolen, and a check-in and a beacon back out to is established with the operating infrastructure as well. Amazon AWS, Cloudflare, along with many other services have been abused to drop these kinds of files in high volume. And at the application's core, it relies on cloud services being available in large quantities to host their PDFs. They could then use this to direct users to malicious links without arousing any suspicion from the cloud providers themselves. The malware would be effective against most workstations if those workstations are not adequately secured.
Operation Cloudhopper is a bit of a throwback, discovered in 2016, which is practically ancient in security years. In this attack, actors carried out a series of sustained attacks against managed service providers and, by extension, their clients. The cloud was targeted throughout the kill chain. First, for the reconnaissance, attackers specifically targeted cloud service companies. Then, in privilege escalation and lateral movement. By leveraging shared infrastructure, they were able to jump between customers' cloud service environments. This was the real key to success. The cloud enabled the attackers' lateral movement. They were able to jump in between using shared infrastructure. There's a hidden level of risk here in that cloud services that isn't visible to the user. Even if a company has done robust due diligence on a service provider, that doesn't highlight the risk that's always there if a hacker is able to breach a relatively weak other customer and move around using shared infrastructure. Shifting workloads and data to cloud providers can let companies feel like they have a false sense of security, but Cloudhopper is a great example that shows that shared infrastructure will always present risks. This campaign was a long one. It targeted managed service providers starting in 2014 and was identified in 2016. Attribution for this is largely given to APT-10, which is a China-based advanced persistent threat group. As discussed, attackers move rapidly from one cloud to another, and there isn't great inter-cloud sharing when something does happen. There's a need for this for incident response and prevention. One idea that we have would be to start a dedicated cloud services ISAC. There are some bug bounty programs that are accepting reports of cloud abuse, such as Google's Data Cloud Protection Program. Outside of this, though, reporting is limited, and cloud providers really should establish direct communication lines with researchers, security organizations, and other cloud providers. We'd really encourage these cloud providers to be more collaborative, and short of having an actual ISAC, additional work around reporting frameworks would be an invaluable contribution to this field.
All right, so we learned that cloud security is not just a product suite that you can buy or a SaaS application, but it's a component of each stage of the attack. There's really no one definitive list also that's being utilized that catalogs all of this. We have seen OWASP and many others start this process, so it's time to build off these existing archival resources and develop them into something more sustainable and similar to Malbazaar or Malpedia. This hive mind will then allow us to network in a collaborative and more rapid and responsive way. If we all have a part in the neighborhood to stay watch and communicate amongst each other, then when we see something bad, we will be able to catch it that much sooner. So here we also provided additional resources and fun reading to learn about how to look for the bad and gain experience.
Special thanks to Malcolm Heath, F5 Labs, Spamhaus, and SANS for helping us in the data. Thank you all so much for being here today.
All right, thank you so much, everyone. And now on to our Q&A.
Lots of great questions coming in for Kim and Remi, so let's get right to them. First one is, were there other limiting factors or things to highlight from your methodology when you analyzed the attack traffic?
Yeah, I can start with this one. So looking at this data, there is a significant limiting factor in that it's honeypot and sensor traffic. So as I mentioned in the presentation, this isn't targeted attack traffic. And the biggest limiting factor in this is that we're not going to know the attacker's true motivations here. That's a big change from when you have data in an organization that's going out, and you can really understand like why someone could be accessing specific ports. So a big limiting factor, especially when we're looking at why there could be potential spikes of data, is there's a lot of unknown there. We try to correlate it to possible world events or vulnerability releases, but we won't actually know that. So it's an important factor in our methodology, just in that we have to give context around that data.
Great, thank you for that one. Next one from Ed, he asks, has Gartner's act of creating new market segments like CSPM or CWPP, instead of expanding the scopes of existing security tools to encompass cloud environments, caused the illusion that cloud computing requires net new security controls?
So when we approached our presentation, we wanted to be able to demystify the idea that uh, cloud security is something that we cannot expand on what we already know from traditional security. And, that said, our message still relays. Remi, is there something else you'd really like to add on to that?
Sure. And when it comes to Gartner and kind of specific market segmentation, I think that we are moving into something where every specific part of security is going to become more specialized. But I think it's similar to what we've seen in the past as well. First, when networking really came out, people got really deep in that, and then it became a bigger department. So you didn't have to specialize in just a specific part of it. So I think that when it comes to cloud computing in general, that's also going to be something similar. Right now, we're very focused on specific vendor products, especially some of the really big public cloud products. And kind of as there's more policy and more growth in this field, things will be a little bit more generalized in the future, just because there's going to be a need for them to all play well together.
Great. Next question. Maybe we'll go to Kim for this one to start off with. What have you found in your research regarding defenders leaning into cloud-specific telemetry that isn't just a relocation or shoehorning of traditional network observables? How do you see the monitoring perspectives shifting?
I really like this question. I think that it ties really well into what we want to do with the V2 of this, which is, now what we're looking at is the attacker perspective and the attacker data. But let's take a look at what this is going to look like and how defenders are going to be able to utilize what we've learned. And so, we'd like to be able to follow up with this question in the next iteration of what we'd like to do. But from the defender's perspective, this is something that we do need to take into consideration, because being able to have insight into the cloud is going to be more challenging, seeing as how, some of the movements and the way that we interact and the patterns of the patterns and observables that we see, they are similar to what, normal known good would look like. So how do we approach that, and how do we identify what is bad and get that insight? That would be in the V2.
Great. Next, we have, what kinds of applications do you see this data in for future work?
I could start on this one and pass it to Kim. I think that the information sharing around this is so important. And so taking this data that does have a limited scope, it could be really applicable if there is a sharing forum such as an ISAC, like we mentioned, or even something that's less formal than an ISAC, but a way for researchers to communicate on a peer-to-peer level. That could make such huge improvements, because it would allow you to see trends before they blow up into something super malicious. Kim, do you have anything?
Yeah, I definitely reiterate that. I think that's this community mindshare is something that we want to be able to support and are really passionate about, because being able to be a part of, providing this type of insight and being able to see the threats as soon as they are elevated is something that we all need to be able to play a part in, so that we can really capture this as soon as it comes out. Cybersecurity is going to be a space where we're fighting against time. And sometimes that does require us all to be able to work together, so that we can say, hey, you saw something? All right, let's work off of this. And a part of that is going to be that.
Oh, I'm sorry. Go ahead, Kim.
Oh, no, I was just wrapping up and saying, yep, a part of that is really that community call out for this mind share.
Great. Now, what I was just getting into is you both have such impressive backgrounds in your, when your work as a father of 4 daughters with growing interest in this field. I'm very interested to kind of what drew you guys to this field. What was your start? How do you guys keep current in trends now? Would you guys share a little bit of your backstory? Maybe we'll start with you, Remi.
Yeah. So I went to college planning on being a history major, and that clearly didn't happen. I realized that I didn't like reading as much as I needed to be a history major. And I had a great professor tell me that if I found something I was interested in, to try and apply it to different segments of my life. And so I was in a couple of computer science classes and I realized that I was pretty good at it. So I kind of kept building on that. And I started with an internship first at the State Department, doing cyber threat analysis and learning the basics of reverse engineering malware. And I learned from that experience that people would pay me not to code, not to be a developer, that I could take the skills and the way that I was learning how to solve problems into different areas. And so from there, I started to try to figure out, is cybersecurity something that I'm interested in? My career had an interesting start after college because I was working for the Department of Defense and I had a commitment to work as an operations research analyst. And so those professors' words really stuck with me. And I just kind of began to try to see, well, can I apply different methods around cybersecurity to some of the stochastic models that I'm looking at and to some of the optimization work that I'm doing? And so from there, I kind of just kept going and I was able to move into more offensive security roles for the Department of Defense before I moved up to Seattle. So I think that it's just, for me, it's been about combining a lot of different interests, specifically looking at kind of how the cyber and physical worlds continue to combine more and more every day. That's how I got into this. Kim, what about you?
Yeah, I love what you shared about just the kept going with it, because cybersecurity is a space that I've identified as, you really can't go, if you're looking for a challenge and you're looking for to identify what is trying to find solutions for very challenging problems, this is the space that you want to be in. So my start, I took a Unix class and I really liked it. So I wanted to keep going with it. And so, I ended up taking a class on a security related class, and I built a malicious PDF, a phishing email, and had put together a backdoor. I phished myself. I did that all within one class session. And I thought, wow, if I can do this, then it's almost like an experience where my mind was blown. And so I thought, well, I really need to learn more. And I've always grown up being really interested in really enjoying mystery novels. And so the appeal for me was being able to be in a space where I can really look at very challenging problems and problems that may not have exist now, and being able to approach how to solve that. And being very, intrigued in that capacity. So for me, as far as an advice, I think the best advice that I've received is, go for it and start now. If you have daughters that are in middle school or high school, so I was a part of Gen Cyber and developed the curriculum to teach cybersecurity to middle schooler and high schoolers. So there are programs out there to teach our next generation how to do this and how to approach cybersecurity in a way that we had not seen it and did not have exposure to. So you can always begin somewhere, and the best time to do it is now.
That is awesome. I truly appreciate you guys both sharing, being willing to share your stories. Thank you for that. We got another one from Ed on Discord asking, would requiring CSPs to offer some sort of WHOIS database reduce the attackers' continued shift to utilize CSPs as reputation mixers / tumblers?
Kim, do you have initial thoughts? Or do you want me to jump in?
Go ahead and jump in on this one if you have something, a strong comment to say on it.
Don't know if it's a strong comment, but what I do think with this is that when it comes to WHOIS databases, there's so much policy and regulation around something like that right now. I think that I'm not sure that it would necessarily be a deterrent factor, especially if some of those same policies get implemented across something like this, just because there's so many ways for attackers to hide. And I'm not sure that in a lot of cases, they even care if their names are out there, especially if you don't have to be using full legal names and whatnot. Monikers that could also then just be seen as a sign of control. So a lot of times in certain groups, actors are really into having their monikers splashed across everything. And I'm sure that in other cases, it would be naming people who aren't involved in it and whatnot. So I think that it's a really important conversation, and that there's definitely more that CSPs can be doing to try to mitigate some of this stuff. But I think that it's also important when looking at the threat models and the way that they kind of think about their threat profiling, about who's really going to be trying to attack them and what those motivations are, so that you can really pull together a defense in depth approach to combat that, like those specific motivations, because it's different for each threat.
Yep, absolutely. And it really does come down to what we intend to do, which is to, is it to really develop a threat intelligence platform? Is it to develop more insight? Is it to defend ultimately? So having that threat modeling, like Remi talked about, is very important.
Great. So we've got lots of questions coming in, and we're down to about 2 minutes. So I hope you guys will be engaged in Discord after this. We can get to all of them. But I'll move on to the next one from Jim asking, can you speak about the interaction of hybrid cloud and insider threat? Any experience there?
Yeah, definitely. I think that what it does is it highlights the need for DLP solutions in a way that are potentially different than what a lot of offerings are right now. I know that that's something that I've been involved in a few RFPs around DLP, just because that is a DLP, for anybody that doesn't know, data loss prevention. So a way to prevent insider threats from taking data or IP off of networks. And I think, so yes, I think that it will play out more in that space, just because monitoring has to be done differently. And anomalous behavior is going to look different in hybrid cloud environments than it does in a traditional on-prem thing where you can really be monitoring files. Do you have anything else, Kim?
No.
Okay, well, maybe we can wrap on this one. We're about a minute, so if we can keep it as short as you can and always finish up in Discord. Vince asks, what should cloud customer security operations staff be monitoring for if they want to be on the lookout for cloud infrastructure compromises along the lines of Operation Cloud Harm?
I'm going to pass that one to Kim, since she has experience in a security operations center.
So I think if the question is specifically along Cloud Hopper, I'd really like to hear, what Remi would follow up with on this. If it's from a security operations center, this, as I mentioned earlier, I think we're talking about defender's perspective and being able to explore what that's going to look like in the next iteration of what we are trying to do here, because our talk here is really looking at the attacker's perspective.
So I'm not a defender, but the things that I would be looking for are anomalous inbound connections. I would be looking for people trying to enter and pivot in ways that just don't make sense. If if that type of account wouldn't be accessing certain resources. And I think trying to make additional outbound connections are some of the top 3 things that I would be looking for.
Great, Kim and Remi, thank you so much for sharing your expertise here at FlowCon. Like I said, lots more questions, so hopefully you're going to get over to Discord here.
Definitely. We have some additional data that I will be posting in Discord.
Yep.
Awesome. Thank you both for that.